Hi, I'm Troy Marshall, Vice President of Thermal Management here at NanoTech Materials. And for approximately the next 20 minutes, I'm going to walk you through one of the most interesting projects we have ever been part of. The emergency rebuild of the retaining wall that holds up the hillside beneath the Getty Villa right on the Pacific Coast Highway. We did something on this job that had never been done before with our Wildfire Shield coating. And before we get started, just a couple of quick housekeeping notes. I'll talk for about 20 minutes and then we open it up and I take your questions. So for the last 10 minutes, we'll have some Q&A. So if you would please drop your questions in the chat as they come so we don't lose them. So with that said, let's get started. The project challenges. Every constraint mattered. None could be traded off. The Pacific Coast Highway is more than just a scenic roadway. It's a designated wildfire evacuation corridor and one of Southern California's most critical transportation lifelines. This is what made the project so challenging. This was not a matter of solving one engineering problem. It was solving several critical challenges all at the same time with no opportunity to compromise, one in favor of another. The first challenge was speed. This was an emergency response project. Caltrans needed the retaining wall reconstructed and the corridor fully stabilized before the arrival of the next wildfire season and winter storm cycle. The project schedule was measured in months and not years. The second challenge was the future wildfire resilience. The Getty Villa corridor lies within a very high fire hazard severity zone. Rebuilding the wall without addressing future wildfire exposure would simply recreate yesterday's vulnerability. The new retaining wall had to be engineered not only for today's conditions, but for the next wildfire event. The third challenge, importantly, was cost and constructability. The project site presented extraordinary logistical challenges. We had steep terrain, limited access, active highway traffic, and immediate proximity to the Pacific Ocean. The Pacific Ocean significantly constrained construction options, as you can imagine. A conventional cast-in-place concrete retaining wall would have substantially increased project cost while extending the schedule, additional forming, placement, concrete curing time, and under emergency conditions, that simply was not a practical solution. The fourth challenge was the architectural integration. This is the Getty Villa, one of California's most iconic cultural landmarks and one of the nation's most scenic coastal highways. Caltrans landscape architecture established rigorous aesthetic requirements for this project. The finished retaining wall needed to blend in naturally into the surrounding environment through carefully matching texture and color, appearing as an extension of the hillside rather than an intrusive piece of infrastructure. The fifth challenge was also very important: safety and environmental responsibility. Construction took place within an active highway corridor, bordered by live traffic on one side and an unstable wildfire damaged slope on the other. At the same time, the project's immediate proximity to the Pacific Ocean demanded environmentally responsible materials. Any fire protection system had to be non-toxic, low VOC, and incapable of producing harmful runoff into one of California's most sensitive coastal ecosystems. So consider what the project ultimately required: a retaining wall that could be constructed rapidly, withstanding future wildfires, remain cost-effective, satisfy the stringent architectural standards, protect workers, and safeguard the surrounding environment, all while rebuilding approximately 6,000 square feet of retaining wall, with sections reaching nearly higher than 70 feet, within one of the most demanding construction environments in the state of California. Those were not independent objectives. They all had to be achieved simultaneously. So this was the challenge. The team, a collaborative success one organization could have not delivered alone. Projects of this complexity are never accomplished by one single company. They succeed because the right partners bring their expertise together with a shared commitment to solving the problem and facing the challenges. This project is an excellent example of that collaboration. Caltrans served as the project owner and lead agency, administering the work under a director's emergency force account. That emergency delivery mechanism enabled rapid decision-making and accelerated construction, allowing critical repairs to move forward without the delays of traditional procurement processes. Skanska, one of the nation's premier heavy civil contractors, served as the general contractor, and their team managed construction operations, field logistics, scheduling, and execution under exceptionally challenging conditions along an active Pacific Coast Highway corridor. Independent quality assurance and field verification were provided by Bureau Veritas. Bureau Veritas was ensuring that project specifications, application quality, and construction standards were independently verified throughout the duration of the project. A key innovation on this project was the off-site application strategy made possible through our manufacturing partner, Squires Lumber. By applying the Wildfire Shield in a controlled production environment before the timber logging was delivered to the project site, we dramatically were able to improve quality control, accelerated installation, and reduced worker exposure within the active highway corridor. As you'll see later, this off-site approach became one of the defining innovations of the entire project. And then finally, NanoTech Materials provided the Wildfire Shield protection system that unified the entire retaining wall assembly. The same coating technology was successfully applied to the timber logging, the structural steel, and the soldier piles and concrete wailers, providing one single integrated wildfire protection solution across multiple substrates, while meeting the demanding performance, environmental, and aesthetic requirements established for the project. What made this project successful was not simply the technology, it was the partnership. Each organization contributed specialized expertise, and together we were able to deliver a faster, safer, more resilient solution for one of California's most critical transportation corridors. What is Wildfire Shield? At the heart of this project, NanoTech Materials Wildfire Shield is a next-generation water-based, non-toxic fire protection coating engineered for critical infrastructure in extreme wildfire environments. Wildfire Shield withstands flame temperatures up to 3,272 degrees Fahrenheit, well above the estimated 2,000 degrees Fahrenheit temperatures experienced during the Palisades Fire. It reduces flame spread and blocks both radiant and conductive heat transfer while meeting rigorous fire performance standards, including the ASTM E84, E119, E162, and E662. What truly sets the Wildfire Shield apart is how it works. Traditional intumescent coatings must react to fire by swelling and forming a protective char layer. Wildfire Shield does not have to do that. Built on NanoTech Materials' patented insulative ceramic particle technology, it functions as a passive ceramic thermal barrier that begins protecting immediately upon flame exposure. There is no activation period. It doesn't need to swell, and there is no sacrificial char. Simply put, the protection is already there. That immediate protection buys valuable time to slow ignition, reduce heat transfer, preserve structural integrity, support emergency response, and protect lives. For the Getty Villa retaining wall, Wildfire Shield protected the timber lighting, structural steel, soldier piles, and concrete wailers with one single integrated coating system. A two-part approach. Let's talk about how we actually delivered this project, because this is where the innovation truly comes to life. The construction strategy unfolded in two distinct phases, an off-site application and an on-site application. That approach fundamentally changed in how we executed this project. At Squires Lumber, for the off-site, approximately 1,500 wood timber lightings were factory coated with NanoTech Wildfire Shield on all four sides of the timber lighting. That approach fundamentally changed how the project was executed. The phase two, the on-site installation. Once delivered, the Getty Villa project, the fully fire-protected timber lighting was ready for immediate installation. More than 16,000 square feet of pre-coated timber was installed along approximately 710 linear feet of retaining wall, dramatically reducing labor, minimizing disruption to traffic, and accelerating construction with one of California's most challenging working environments. By separating the project into two phases, precision coating off-site and project installation on-site, we have transformed what would traditionally be a labor-intensive field operation into a streamlined, highly efficient construction process. The two-phase approach became one of the defining innovations of the Getty Villa retaining wall project and laid the foundation for faster, safer, and more scalable model for future wildfire-resistant infrastructure. This project marked a significant milestone for NanoTech. For the first time, Wildfire Shield was applied off-site before installation. Although Wildfire Shield has never been successfully used, although Wildfire Shield has been successfully used on dozens of Caltrans projects and thousands of square feet of transportation infrastructure all throughout California, the traditional application method has always been the same. Fire protection coatings are typically applied after the retaining wall has been installed and constructed. For the Getty Villa project, we challenged that conventional approach. Instead of coating the timber after the installation, we fully encapsulated every replacement timber lighting panel on all four sides at the Squires Lumber facility in Tucson City. That may sound like a simple challenge, but it fundamentally changed and transformed the construction process. Interesting, the barrier had never been the coating technology itself. It wasn't a chemistry problem. It was actually a construction workflow problem. For decades, wildfire protection had been treated as a field operation because no one had developed a process that integrated fire protection into a manufacturing phase of retaining wall components. By shifting the fire protection upstream in the construction sequence, we have transformed coating from a field activity to a manufacturing process. The result was higher quality, greater consistency, improved worker safety, faster installation, and more efficient project delivery model. And most importantly, we demonstrated that the approach is not limited to a single project. It establishes a repeatable methodology that can be adopted on future transportation projects and creating a new standard for developing and delivering wildfire resilient infrastructure throughout California and other wildfire prone regions. Why this off-site application process transformed the project? One, reduced on-site labor. The labor-intensive coating process was completed prior to delivery, substantially reducing the workforce and installation time required in the field. Two, weather-independent production. Application was no longer dependent on field conditions by coating the materials indoors. Three, superior quality control. A controlled manufacturing environment ensured consistent film thickness, proper curing, and uniform coating quality. And four, shorter highway impact windows. Because the timber lagging arrived pre-coated, installation crews were focused on placement and replacement rather than coating operations. So perhaps the greatest benefit was improved safety. By relocating the majority of the coating work from a steep hillside and an active highway, we were able to control our worker exposure to traffic, difficult terrain, environmental hazards that we significantly reduced. The result was safer, more efficient, and the process lowered the project risk while improving quality and scheduling performance. Delivering the fire protection without compromising aesthetics. One of the project's greatest challenges was to balance the performance with appearance. The custom textured wildfire finish, a capability that had never been implemented with the product, the finish was engineered to satisfy the stringent visual requirements by District 7's Caltrans architectural engineer. The true engineering challenge, however, was not ensuring that this enhanced aesthetic finish did not compromise the performance. Changes to a coating surface profile and texture can influence protective characteristics, requiring careful formulation and application. The result was a solution that demonstrated aesthetics and fire performance that do not have to be competing priorities. On the Getty Villa project, both were achieved without compromise. Let's take a step back real quick and consider the true purpose of the retaining wall. It is far more than a structural feature. It is a critical piece of infrastructure, safeguarding the stability of the hillside that supports the Getty Villa, nearby residents, Pacific Coast Highway, and other valued public assets. If the retaining wall were felled during a major wildfire or subsequent erosion event, the consequences could extend far beyond the wall itself, affecting surrounding hillside, transportation corridor, and neighborhood properties. The importance of protecting the structure cannot be overstated. Within our team, we often refer to the Wildfire Shield as the friendly neighborhood Spider-Man of the project. It's not the feature that draws attention, and most people driving along the highway will never know it's there. It's like an unseen guardian. It quietly performs one of the most important jobs on the project, protecting critical infrastructure behind the scenes so community can continue to travel, live, and work safely. So the key takeaways, first off, I would like to conclude with the offsite application is scalable and is fundamentally changes the economics of construction. Secondly, one coating system protected an entire multi-material assembly. And third, reducing field work improves safety and productivity. Fourth, environmental stewardship was built into the solution. And fifth, fire protection and architectural aesthetics are not mutually exclusive. Wildfire Shield is a ceramic thermal barrier and is not an intumescent coating. And it is equally important to long-term durability. I wanted to mention that coming up soon, this innovative project will be featured on the television series How Did They Fix It? Scheduled on the air to air on Paramount later this year. The episode will showcase the engineering challenges and the collaborative solutions, innovative construction techniques that made the Getty Villa retaining wall a project success, highlighting its model for resilient infrastructure in wildfire-prone environments. So wrapping up, that is the PCH in a nutshell wall. It's a burned out hillside on the most iconic road in California, rebuilt fast, rebuilt to stand up to the next fire. If you have got infrastructure sitting in fire-prone areas or just want to dig into the numbers, please come talk to us. You can reach me and the team at nanotechmaterials.com. If you're a contractor and applicator, call us and ask us about our wildfire program. We're rolling out wildfire nationwide, and we would much rather put it in a trained applicator's hands. So with that said, we've got a few minutes left, so we're going to open the floor for questionings. We're going to address some of the questions that have been asked. I see here Wesley was asking, what's the field application method you used? Does it change at height? No, so the application in the field is the use of a hopper gun texturizer Graco spray pump. And for this particular project, because we had very large heights and we had to move fast down the wall, we used a man lift, and we were able to lift the spray pump up on a man lift and travel down the wall rather than setting up scaffolding and having to keep moving. It was more efficient. So thank you for that question, Weston. Can Wildfire Shield only be applied to wood or other infrastructure substrates? No. So on this particular project, we were able to, we coated the concrete and the steel soldier piles. The concrete was coated because concrete and both steel will lose its integrity at high temperatures, and it was important for the concrete to not conduct heat transfer because of the cable infrastructure anchoring the retaining wall. It looks like that is all the questions. We'll hold out for a little bit longer, see if anybody has any questions. With that said, in closing, it was for myself and the NanoTech team, Caltrans, Bureau Veritas, Skanska. It was a pleasure to work with the team on such an iconic project, and we look forward to the next infrastructure project protecting the high value in our communities from the wildfire conditions that we continue to see.
Troy, we got one more in the chat. I'll pop it up for you real quick.
One more? Okay. Can offsite application be repeated, or was that a one-off? No. So we had trained application to our application partner in lumberyard, Squires Lumber in California, and they have since been looking for future projects and applying our coatings on other timber infrastructure to harden infrastructure for wildfires. So we look forward to training other partners in other parts of the country in the wildfire area, and it is a scalable and repeatable method for protecting highway infrastructure. Okay, so what's next? Coming up, we got a cool roof webinar. So join us to learn about our flagship product with our cool roof coat in July. And then we'll have another one following up with our particle guy webinar in August. This is our research and development director that will explore the bounds of our insulative ceramic particle. So don't miss out on any future webinars from NanoTech. Follow us on social media and stay up to date on our latest events. We thank you very much.